Welcome to the third lesson in series and parallel circuits. In this lesson, we are going to compare the resistance in the circuits. Before I continue to do that, I would like to mention Ohm's law. Ohm's law states that the potential difference across the ends of a conductor is directly proportional to the current in the conductor. If temperature is kept constant. We know that if a resistor heats up or a conductor heats up, the resistance increases, so more energy would be used to push the same current through the resistor. So in mathematical symbols, potential difference is directly proportional to the current. Now the ratio between the potential difference and the current is also known as the resistance, and in this equation the resistance is the proportionality constant in the ratio between voltage and current. So basically I can rewrite that equation into a more familiar form, I times R, or R is V over I. We'll discuss Ohm's law in more details at another occasion. Right, I've got my series circuit and my parallel circuit. The cell I will keep 1.5 volts. We said that in a series circuit, the potential energy divides in half if the resistance is constant. So this voltmeter will read 0.75 volts, 0.75 volts on this side. And on the parallel side, we said that current is divided, not the potential difference. So 1.5 volts there, 1.5 volts here. I want to now determine the resistance in the circuit. So let us say we've got identical resistors and a current of 0.2 ampere flows through the circuit. Now that current flows through the first resistor as well as the second resistor. So in order for us to calculate resistance of resistor 1, it would be, if I use Ohm's law, V1 over I, so that is 0.75 divided by 0.2, and that would be 3.75 ohms. So resistor 1 and resistor 2, they're identical, so I can write here R2 is the same as R1. What is the total resistance in the circuit? The total resistance in the circuit would be the total voltage divided by the total current. The total voltage is 1.5, the total current is 0.2. So 1.5 divided by 0.2 would be 7.5. And the unit we measure it in is the ohm. Now here I can see that if I look at the sum of R1 and R2, I will get 3.75 times 2. 3.75 and 3.75, and that adds up to 7.5 ohms. So the total resistance in the circuit is the sum of the resistors connected in series. Total resistance is the sum of resistors in series. If we flip to the parallel circuit, something very interesting happens. Now, if I use the same resistors in the first circuit, in the series circuit, as in the parallel circuit, let's see what happens to the total resistance in the circuit. So R1 is 3.75 ohms and R2 is 3.75 ohms. So I want to know what is the current in the first resistor. Current, if I use Ohm's law, current would be the voltage across the first resistor divided by the resistance. If I continue on this, it's 1.5 divided by 3.75. So 1.5 divided by 3.75 gives me a current of 0.4 amperes. And because the resistors are identical, the current through the second resistor would be exactly the same, 0.4 amperes. Now, parallel connected resistors are current dividers. So in that case, the total current in the circuit is the current through the first resistor plus the current through the second resistor. So it's 0.4 plus 0.4, which gives us a 0.8 ampere. To calculate the total resistance in the circuit, we have to take the total potential and divide it by the total current. And doing that, I get 1.5 divided by 0.8, and that gives me a 1.875 ohms. So, what is the relationship between the 1.875 ohms and the 3.75 ohms for each resistor? For this, I will need some more space. Now, it is very interesting to see that if you add resistors parallel to a battery, you're actually decreasing the total resistance in the circuit. So, we need to go on to mathematics where we add the inverse of the resistance to calculate the total resistance. So, the total resistance in the circuit, if you have parallel resistors, is the sum, the inverse of that is the sum of the inverse of the individual resistors. So let's see what happens. What is 1 over 3.75 plus 1 over 3.75? So that would be 2 over 3.75, which is 0.53 repeated. If I take the inverse of that, I get the total resistance in the parallel circuit, which is 1.875 ohms. So this is a new mathematical relationship where if you want to calculate the total resistance in a parallel circuit, you need to invert the resistors and add them to get the inverted total resistance, and then get 1 over R T, and then inverse that to get 1.875. I know this is the first time that we are really looking at this, so I hope in the next contact session that we will be able to describe it in more detail. The point is that the more resistors you connect parallel to a battery, the lower the resistance in the circuit would be, and for a series circuit, the more resistors you connect parallel, the higher the resistance in the circuit would be. See you in our next class.